Well, my 18650 lithium ion solar charging portable generator is pretty much finished. And I'm going to give you a little walkthrough. So you can see there's the voltage, there's the output voltage, and this is drawing 150 watts. 14.7 volts in, 120 volts AC out, 150 watts. Running a couple of lights in the camp. You can see some of the wiring I did. All the white is positive, all the black is negative into the what I call my bus bars, but they're actually neutral bar or grounding bar kits out of a Square D load center. Master disconnect, fuse underneath, solar charge controller, 100 watt solar panel coming in, 1500 watt modified sine wave inverter, and of course all my battery packs. 4S by 3P per pack, 24 packs, so 4S 72P for 288 cells. Still doing a lot of experimentation and measurement. I'm trying and recover this pack, and it seems to be working. So we'll see. I've got quite a few more I might be able to recover. We'll see. So a lot of questions. Well, one of the main questions I've been getting is how much did this cost? So I basically did including tax, a bit of rounding. The solar panel was about 130 bucks. The cables from the solar panel into the charge controller were about 50. The charge controller was about 30. The battery bank I got from recycled old batteries. The inverter was about 200 bucks. A fuse holder was 20. 150 amp fuse was 10. Disconnect switch was 40. I changed all my wires from double aught to 2 AWG. Including the lugs, so it was 30 bucks for different wire, 35 bucks for the lugs, about 25 bucks for all the male blade connectors. That's all the little blue guys in here. The tote, it did fit in the smaller 64 liter tote, 15 bucks. My two grounding bar kits were about $30 each, so 60. So in the end, I spent 645 bucks on a fun project, and I learned a lot. So here we are. So I wanted to run through the setup here a little bit. So the solar panel is 100 watt monocrystal, open circuit voltage 21.6 volts, maximum voltage 18 volts, open circuit amperage 6.11 amps, maximum amperage is 5.55 amps. So you can, yeah. And then the charge controller, it's possible to handle 20 amps charging in. Your solar's got to be less than 50 volts. Battery bank, as I said, lithium ion, 18650s, 288 cells total, 4S 3P per pack, 24 packs, gives me a 4S 72P. The inverter is 12 volt DC in, 120 volt AC out, 1500 watt modified sine. Now, basically, I want to quickly run through what's limiting what. So the solar panel has a maximum of 18 volts that it can produce when it's actually plugged into the battery bank. So as long as I'm over, I'm going to come back to this 15 volts, but so the charge controller is a big limiting factor, as I knew before I started all this, but the highest allowable charge that the charge controller will send to the batteries is 15 volts. And I'll finish that off later. So when you're talking about 18650 cells, ideally your maximum voltage per cell is 4.2 volts. The nominal is 3.7 and the low is 3. You try not to go under 3. So multiplying that voltage times 4 in series, you get 16.8 volts at the top, 14.8 in the middle, the nominal, 12 volts at the bottom. So you can see that the charge controller will not let me charge up to my allowable maximum voltage. So that is a shame. You lose quite a bit of capacity that way. However, I can set my limits on the charge controller to appropriate limits. However, the inverter is still gonna keep running. It'll go down. It'll start alarming at 11, and it'll actually shut off at exactly 10. And it can handle up to 16.3 volts. It'll shut down at 16.3 volts. It'll start alarming at 15 volts, and its normal range is between 11 and 15. So my upper limit of everything is unfortunately set by the charge controller at 15 volts. I would much prefer if it could go up to 16.3, but it doesn't. The lower limit is set by the inverter because it'll actually shut off at 10 volts. But I keep an eye on it. I don't really let it go down that low. I don't use it for that long anyway. But if it were to go down to 10 volts, that would be 2.5 volts per cell, which you can see is lower than 3. It's not recommended. It supposedly will cause damage to the cell, potentially reduce its capacity, definitely reduce its number of charging cycles. At the alarm setting, if you're around and you hear it start to alarm at 11 volts and turn it off, you'd be at approximately 2.75 volts per cell, a little closer to your bottom of 3. So I'm definitely leaving some capacity on the table by not being able to charge all the way up to 16.8 volts. So theoretically, 3.7 volts nominal per cell at 2.2 amp hours per cell times 288 cells gives me theoretically 2,344 watt hours. However, I'm only getting approximately 3/4 of the capacity because I'm undercharging. I'm only going up to 15 volts because that's the most I can get the charge controller to give me. And I could go up to 16.8 volts. So basically I'm only getting 3/4 of the capacity due to undercharging, and I'm estimating about 3/4 of the capacity because this is all recycled old batteries. So I believe I'm actually ending up with approximately 1,300 watt hours. And by my first test, that seems to be about right. That's about what I was able to get out of the system the first time I ran a quasi test. So there's the rundown on my my little portable system. It all fit in the box, no problem. I've just got it pulled up here, up high, just for ease of showing everything and dealing with stuff right now, but it all fits in the box, no problem. There's my rundown. More testing to come. Any comments that are in any way constructive, even if they're stuff I've done wrong or stuff I could do better, is accepted and appreciated. Wanted to send out a quick thanks to another mechanical guy, PB. He helped me out with all the crimping. Much appreciated.